Alright, hi everyone, welcome to my YouTube channel, 2's Lections. And in this video we'll talk about 2's complements. Last video we talked about 1's complement, and this we'll talk about 2. And obviously we've already said that the 2's complement of a number is given by this. Okay? Now, where R is the base, we've said that of the number, N is the number of bits, and capital letter N is the number itself. Okay, but we know that that's the positive of the number. Complement, you are taking the negative. That is, we are looking for the complement of the negative. So N is the positive, so we can just simply say N is the number. Okay, so we can also get the 2's complement of a number by first finding the 1's complement of the number, then add 1 to the answer in order to give us 2's complement of the number. Remember that the 1's complement of a number is given as this. I believe you remember that from the previous video. Thus, 2's complement of a number can be written as, this is the 1's complement, from here to is 1's complement. Okay, once you add 1 to it, this 1 will add it to this 1. 1 plus minus 1, that's 0 now. So which also is the same as saying R is per N minus 1, exactly 2's complement. Okay, I also said 2's complements can just be written as this. Okay, and of course the minus N is outside, minus N. So this is also the same as this. Makes sense. Okay, using arrow in place of 2 is just like saying in the general form. Okay, now let's take an example and get done with 2's complements. So for example, let's find the 2's complement of this number. Okay, so how many bits do we have here? 1, 2, 3, 4, 5, 6, 7. 7 bits. So since there are 7 bits, it simply means we'll have 7 0 now. Okay, we did something like this in the previous video. For 7 bits, it means we'll have 7 0. There will be 1 and then 7 0. 1 and 7 0. When you subtract 1 from it, we are doing the 1's complement inside the 2's complement now. When you subtract 1 from it, what do you get? You get 1, 2, 3, 4, 5, 6, 7. 7 1 exactly. It's just like, let's go back to this. It's just like for our 1's complements. When the number of bits is 4, how many 1 1 1 do you have here? 4. 1, 2, 3, 4. A short way to look at it. If your number of bits is 4, you have 4 of the 1. If your number of bits is 7, you have 7 of the 1. Just simple as that. Okay. However, okay, yeah, that's done. Let me not oversimplify. So we want to find the 2's complement of this number. There are 7 digits. There are 7 bits rather. Okay. So these 7 bits, which means we have 1 0 and 7 zeros. And when we remove this 1 from it, it will give us what? 1 2 3 4 5 6 7 of the 1 minus the number itself. Okay, this will lead us to this. There we can now add 1. If you think of it, guys, what we have inside here, okay, is the opposite of this. Look at it now, and that is what? Exactly 1's complement. Now we are adding the 1 that will make this first bit 1. Exactly what we said just now, saying that we can get the 2's complement of a number by first finding the 1's complement of the number and then add 1 to the answer in order to give us the 2's complement of the number. Okay, so that's what we just did here. Inside is exactly 1's complement. So we carried out 1's complement operation and then we add 1 to it to give us our 2's complement. Okay, how many number of bits? N is 7. Since there are 7 bits, we have what? 1 2 7 1's. What we mean by this part, let me just explain this part quickly. We have 1. Okay, let me see if I can write it right here. 2 raised to power 7, right? This will give you what? If you do the calculation, you will get a number, let's say 2 times 2, 4 times 2, and we get a number. Let's do that quickly. But whatever you get, you always land at this part. Okay, you always land at that part, believe me. Okay, so let's see. 128. Okay, so this will lead to what? 128. If you remove 1 from it, which is this one here now, 128, remove 1 from it to give you what? 127. It will give you 127. 127. Now convert this thing to base 2. Okay, just like I did in the previous video. You are going to end at this number. This way you are going to land. Okay, then when you subtract 1 from it, you will land at this number, and then you minus this guy, which is this guy. You minus it from it, you will land at this number. And then you just add 1. So just a simple way to look at it. Remember the shortcut for 1's complement. Where is this now? The shortcut for 1 complement. Turn everything to the opposite. Here will be 0, 1, here will be 0, 1, here will be 0, 0, here will be 1, 0, 0, 1. Exactly. Just do that. 1's complement. And then add 1 to it. Case closed. You've gotten 2's complement. So note, our final answer is simply the inversion of n. Like we said, that inversion of n is 1's complement. Now with the addition of 1, when you add 1 to it, that's 2's complement. Add 1 to 1's complement, you get 2's complement. So without using the formula, 2's complement can be formed by leaving all the least significant zeros and first one unchanged, replacing zeros with 1's and 1's with zeros in all other higher significant digits. So we can try that in example 2. Let's find the 2's complement of this number using the idea given above. So from step 1, the first 3 digits from our right will remain the same since we have zeros before a non-zero digit. So all this one will leave them the same because this is the least significant bit to our right. Since they are 0, we leave them to our right. Then when we get to the first non-zero, we also leave that one. From this point down, we are going to invert them. So we invert the rest in all other higher significant digits. So that will now give us what? Here will be 0, here will be 0, here will be 1, here will be 0. Then the rest will remain the same. Exactly what we have here. Okay, now if we use the idea of let's try it using the formula. So how many digits do we have? 1, 2, 3, 4, 5, 6, 7. So that will give us what? 1 with 7 zeros. And when we subtract 1 from it, we get what? 7 ones. And then minus this number. That will give us this, which is the inversion. Plus 1 will give you this. Everything remains exactly the match with this. Okay, perfect. So yeah, we see that both answers are the same. That is, we can make use of any approach to get 2's complement of a number. And that's where we're going to we'll stop here in this video. And like, share, subscribe, comment, and I'll see you in the next video. Thanks for watching. Bye for now.